Okay, let's jump into source transformation. So it turns out, as I said last time, here we are reviewing source transformation. And what we said last time is that if you have a voltage source in series with a resistor, and there's that network is connected to, let's say, the ports A, B here, right? You can replace that network. So everything to the left of this thing here, you can replace that whole network as long as it's equivalent about the ports A and B. You can replace it with a current source in parallel with a resistor. And what you have to do is transform between these two things to figure out what is the value of IS and what is the value of R if you're going to transform this circuit. Now, if you're going to transform this circuit, it should be equivalent. So whatever you replace it with should be equivalent for any load attached to a B. What you want to look at then are the extreme cases. The extreme cases would be a short circuit. So what about if we looked at, and the extreme cases would also be an open circuit. So let's take a look at a short circuit here. Okay. So no matter what we replace it with, it should look the same. If we go ahead and short this, we place a wire there from A to B, and we now have a load current IL. If we were to do the same thing over on this circuit, the two currents should be the same, right? So IL really should equal IL, right? If this is to be truly an equivalent circuit as seen by the load. Okay, so let's take a look at the left case. If we wanted to find IL, that's traveling through here, right? That's IL. Well, you've got that voltage source in series with a resistor, so IL is just the value of that source divided by R, right? You just take VS divided by R. That's how much current is going to flow through that, right? Simple Ohm's law. Okay, let's take a look at the right circuit here. On this one, what do we have? IS is flowing this way, right? And then is it going to flow down through R? Maybe not, right? Because it's shorted, right? R is shorted. R is in parallel with a short circuit. And so all of IS is going to flow through IL. Nothing is going to flow through the resistor because it's been shorted. And so IL is just equal to IS. All right, so if we go and then say that the left, oops, hang on there. The left-hand side should be transformable to the right-hand side. So what we have then is, as we said, IL should equal IL, or that we have VS over R on the left side, right? This is IL on the left side, must be equal to IS. And as it turns out, so that's how you transform between the two voltage source, between a current source and a voltage source. And it also turns out that the resistance is the same resistance, R. So to summarize, you can replace everything to the left of this dashed line. You can replace that series, that voltage source in series with a resistor, this guy here. You can replace it with a current source in parallel with a resistor. And how do you find the value of IS? If you're transforming from a voltage source to a current source, just take that voltage source VS, divide it by R, and that's your value for IS. Okay, and then the resistance R is the same in both circuits. All right, so for independent sources, you can transform from voltage to current source or from current source to voltage source. Again, the relationship is just this one. It's a real easy one to remember because if you take a look at it, what does it look like? It looks like a law we use all the time. It looks like Ohm's law. You know, there's a reason that it looks like Ohm's law. It came from, you know, from this right here. This is Ohm's law right there. And in this case, this is just the amount of current flowing through the load. So there's good reason that it looks like Ohm's law. Okay. So for independent sources, you can transform between them just that way. The resistance never changes. So if you're going from V to I, then it's I is equal to Vs over R. If you're going from a current source to a voltage source, then the voltage source Vs is equal to R times Is. Okay. Now, if you have dependent sources, so let's say you have like a source like this, like it's like KVX there, then this source over here is going to be, if I just circle this here, so that's the voltage source, right? Let's say it's like 4 Vx or something like that. So K would be 4. The value of the dependent source would be 4 Vx or KVX divided by R. Right? So if this was like 4 Vx, then this whole thing would be 4 Vx over R, like that. Okay? So that's how you do it for dependent sources.